So our consortium contains 17 partners from 7 European countries, which include Czech Republic, Italy, France, UK, Germany, the Netherlands and Belgium. We have 7 R&D centers in this consortium and 10 industrial partners, from which 3 are rather large companies and 7 are high-tech SMEs. These partners, or these industrial partners, are from various fields in the production chain, which include the chemical and the biochemical industry. We have Transferant Chemicals, Tecnaro, Rodenburg and Devan. On the side of natural fibers and processing, we have La Zéloise from Belgium and Agritech from Czech Republic. And on the side of extrusion and agrotextile producers, we have Bonar, Enya, DS Textiles and Texinov. So this slide gives another overview of the partners that are included. So some highlights of the research results that are obtained during the project. On the side of natural fibers, we studied jute, linseed, flax, hemp. We studied the enzymatic treatment and what this effect was on the harvesting of the natural fibers. We studied various furan resins and how it had its influence on reactivity, hydrophobicity, and also flexibility of the textile material. And this was applied to our eventual non-woven fabrics, and it showed that the strength of our materials could be increased. Together with this, also the stiffness increased, but we saw a decrease of degradation. We saw this in soil burial, and also we were able to use less textile material, so reduction of weight that was necessary for the effect we aimed at. This is an example of a soil burial test. So on top you see the reference, and on the left side the original material, on the right side after 42 days of soil burial. And below you see the treated textile material, which shows clearly an extended lifetime. We studied starch-based textile materials, but frankly the results in that area were less promising. We showed that processing of tapes and monofilaments was possible, but on the side of mechanical properties we are still limited, so we need further improvement on that side. On the side of PLA, however, we had quite good results with monofilaments, multifilaments, tapes with mechanical properties between 20 and 40 centinewton per text. Good processability in non-woven materials, woven fabrics, knitted fabrics. So in this field we had some promising results, and we are also further elaborating to incorporate added functionalities such as controlled degradability, flame retardancy, etc. So this is one of the results which shows the evaluation of PLA during soil burial. So it's a PLA filament, and we see that after 84 days in the soil that we still have good strength of our materials, so high stability. Also, with regard to UV irradiation, we see good resistance. We see, for example, that up to 2000 hours we have a good mechanical strength. It's only after 3000 to 3500 years of UV irradiation that we have a strong decrease of tensile strength. On the left you see a picture which shows the brittleness of the material after 3,500 hours. So we have some demonstrators obtained, and we test them in real life in 2 locations, basically in Italy, one in the south of Italy in Brindisi, one in the north in Genova. Next to that, there are also tests with partners at our own sites. So why these 2 locations? Well, in the south of Italy, the climate is quite sunny, hot, dry, and it's an area near the coast, and it's a flat area. In the north of Italy, there is less heat, there is more humidity, more rain. There are hills, rocks, and it's near the coast. The first demonstrator is a jute non-woven, which can be used as a ground cover. It's impregnated with a furan resin to control its properties. It can be used, for example, as a cover for flower pots. It can be used in landscape application in public areas, and it has a lifetime of 1 to 2 seasons. So one of the great advantages is that there's a big reduction in used material, up to 50%. On the next slide you see a practical application of the demonstrators to evaluate its real life usefulness. The second demonstrator is a knitted fabric based on PLA. So on the left you see it can be used directly on the crops, or it can be used as shown in the picture on the right as a textile material on the greenhouse. It gives some controlled aeration. It gives also, of course, cover from insects and stuff. DS Textile has a non-woven PLA-based material, where you can see that the seeds are included in the textile material. So the aim of this material is to reduce soil erosion, and also to be used as grass mats, and it has a durability of 2 to 3 years. A fourth demonstrator is PLA woven material, which can be used as ground cover, either as seasonal vegetable or flower garden use, or as a landscape application in public areas. A typical lifetime of these materials is 3 to 5 seasons. The evaluation of these demonstrators will mainly depend on a visual evaluation. Next to that, samples will be taken on several intervals, and evaluation will be based on tenacity and molecular weight. Next to that, we also have some toxicological evaluation of impact on crops and plants. We already obtained some commercial products in this project. One of them is bio-based Filbio, which is a knitted textile material, or insect screen, which offers controlled climate, aeration, light and humidity. This is from Texinov in France. A second commercial product is from DS Textiles. It's PLA-based non-wovens, which can be used as ground covers, and the commercial names are Hortaflex and Weed Control. And then we have a Duracover from Bonar, which is woven PLA tapes, which can be used as ground cover with 3 years guaranteed durability. So as a final conclusions for this BIOAGROTEX project, we have already obtained quite some promising results, also some commercial products. In the area of natural fibers and bioresins, we obtained reduced weight, improved mechanical properties, extended durability. On the side of PLA, we obtained good processability and mechanical properties, high durability, and also good degradation in composting conditions. So we can say that we actually do have a range of 100% bio-based textile products. Finally, let me thank the European Union for subsidizing this project, scientific officers Rieke and Barrero, the technical advisor Mr. Cauchy, the European Commission for financial support, and thank you for your kind attention.